Hello everyone, welcome back to another video. So, in this video, I want to talk about some automotive fundamentals. So, this video is out there for you guys who are currently in your college automotive club, who are about to participate for your SAI or SAE competitions, Baha competitions, ATVC or ESVC competitions, or any other automotive related competitions. And this video is kind of a refresher or beginner video, so to say, where I'll be covering off fundamental concepts in as simple of manner as possible. Well, of course, I'll try to be as straightforward with the concept as much as I can. But if you think I have missed some point anywhere, and or if you want me to elaborate anything, then please do reach out to me through the comments. I'll definitely come back and answer them. I'll be straightforward with you about what concepts I'll be covering in this video. So it'll be about the wheelbase, the track width, the CG or center of gravity height, and the chassis height. Okay, okay, that's it for the intro part. Now let's get into the video. Okay, so the two main fundamental dimensions when you talk about any car or any automotive is the wheelbase and the track width. Now, why are these important? Let's just explore them now. Starting off with the wheelbase. Okay, so the wheelbase by definition is the distance, horizontal distance between the rear and front tire centers. Now, this wheelbase parameter is the one that determines the ride stability, the comfort, and also the handling. Now, let me elaborate, okay, on each of these concepts. Okay, starting off with the comfort. Okay, so take a look at this picture. So when the car is accelerating or when the car is braking, that time when you sat in the car, you might have obviously felt that jerk, right? You know, the forward motion, or when the car is braking, or when a sudden backward push when the car is accelerating, right? If you have a car with longer wheelbases, like say take a car like Innova Krista or take a car like Ford Endeavor, Kia Carnival, Kia Seltos, all these big cars. When you sit inside them and you accelerate, you don't feel that high of a jerk. Okay, Uh, and why is that? Well, because of the longer wheelbase, the what do you say? The turning effect produced by the a sudden acceleration or deceleration is counteracted by the normal reactions on both the front and rear tires, and because of that, you don't feel that jerk very immediately. And plus, combined with the fact that you have a suspension, uh, you don't uh, you don't get to see it that often. That kind of a jerk. Next thing is take this example. Okay, when you are going in a car with longer wheelbase and car with a shorter wheelbase on the road, and you face some obstruction like a speed breaker, a hump, or a pothole. Okay, what happens is that in a car with a longer wheelbase, the pitching motion, right? The pitching motion is just created by the obstruction is lower for cars with longer wheelbase as compared to that with shorter wheelbases. Because of that, the rider who is sitting inside the car, right, he does not experience even when the obstruction is there and the car is going over it, the total pitching motion is so minor that he just considers that the car is going on plain road, and because of that, uh, the overall rider's experience, the comfort factor will come in, and that's how cars with longer wheelbases tend to be more comfortable. Okay, you get the experience, right? The comfortable experience. That's how you get it. Only in case when you have a shorter wheelbase, that time you feel such sharp changes in your pitching angle that you feel the obstructions. You feel every single obstruction on the road, be it the tiniest of the speed breaker, the tiniest of the pothole, you feel it that time. Now this is only just considering the wheelbase. Now imagine when you have suspension system added in. Of course, the longer wheelbase cars will not feel it at all because the suspensions will you know, complement the wheelbase geometry, and the rider inside will never even make a guess, second guess, that the obstruction has been passed over. But only in the case of shorter wheelbases, even with the suspension set in, you are more likely to feel the sudden sharp pitches in your motion. Another obvious parameter when we talk about cars with longer wheelbases is that the total region available inside the car, okay, compartment, if you know what I'm talking, the compartment space which is available inside the car is more. So that means you have more space to add more and more amenities. You can have a whole entertainment system. You can have a luxury sofa over there. You can have a whole bed setup, and many more things. So it's up to the rider, or it's up to the person owning the car to decide what all can go inside, and that luxury of space is available when you have longer wheelbases. Now, is it always good to have longer wheelbases? No, not really. Uh, when you have the comfort of longer wheelbases cars, at the same time, you must take into consideration that they are not very responsive. Okay, like say in the case of taking a turn. Now, of course, the rider sitting inside the car, he'll not feel it. Okay, he'll not feel that you're taking the. Okay, good. But at the same time, the car should make the turn, right? Say you're taking a sharp turn. The cars with shorter wheelbases will be able to do it more gracefully, because uh, the turning radius of such cars is shorter as compared to the cars with longer wheelbases. If you take a longer wheelbase car and try to go on the same, uh, tight curve, uh, you might pretty well know the experience that you cannot do the curve in a single go. You'll probably have to take a turn, then come back straight, then take a turn again, go forward, come back, and repeat this a few more times, and then exit the turn. That's what makes the cars with the longer wheelbases a little more difficult when you're doing cornering. And in terms of handling gaps, also the steering is not very responsive. So you feel like you have to put a lot more effort to just turn even the slightest bit. So yeah, that's that about wheelbases. So what's your takeaway from this? What should you take away from this in order to implement this for your car? Uh, Choose a wheelbase such that it's able to accommodate enough space for both the driver, the engine or the motor, the transmission, the batteries, and everything, uh, and just keep a bit more of additional value along with that, and that sets the value for the wheelbase. If you make it too big, then when you're doing tight turns, it will definitely cause more problems to you. So choose an optimum value which is just able to satisfy all the parameters which I just said. Along with that, some clearance value or some additional value, which makes the rider feel a bit more comfortable with the space available to him. Okay, so that was about the wheelbase. Now let's move on to track width. Okay, so or it's also called the wheel track. Track width is defined as the distance in the center line of one tire to that of the other tire, and these two tires like the same axle. Okay, if you have to measure practically, then we take something called the contact patch of one tire, which is the area under the tire in contact with the ground. So we take the center of the tire contact patch and uh, measure it all the way to the other tire contact patch center for the two tires which lie on the same axle, and that distance we track with. Okay. Now, first and most obvious reason for having a wider track width is aesthetics. Look at these cars. What do you see common with the wider track width? The wide, aesthetic, mean dragster kind of look. No, that is achieved because of having a wider track width. Uh, Now, if I am given any one of these cars, and any one of the commercial cars, uh, just in terms of design aspects only, I can tell yes, this is the car which I'll choose. These cars are the ones which I'll choose. They look so good. Okay. Now, track width not only gives him that aesthetic looks, but there's also technical reasons for having wider track widths. Always aim for a wider track width. Okay, the larger the better. The only consideration comes in when you are taking packaging into consideration or transportation into consideration. Say when you have to load your car into a trailer and trailer is only this wide while your track width is this wide, it does not help. And also take in consideration how much limit you have as per your SAE or ESVC rules, how much wide your body can be. My suggestion is take as wide as a space as possible because that will always help. In track width, it's not necessary that the front and rear track width will always remain the same. In most of the cars, you always see that front and rear have almost the same dimensions. Even if they're different, you can't generally make them out. But say you're doing top speeds or when you're doing very very tight turns at top speeds, that time you need to have wider track widths. The same case of go karts. So in go karts, we have top speed, yes, and they're also doing tight turns. And you know, in tight turns, centrifugal force is always trying to pull you towards the outer edge of the track, and it's trying to roll you over. So, how do you contract this? You use a larger track width. Now, you might ask, okay, fine, let's use a larger track width, but how does it help? So, think about the torque or the rolling force which is acting on the vehicle over here. So, during a tight turn maneuver, the centrifugal force is providing a rolling force or a torque along the outer wheel, about the CG, right? So, at the same time, this centrifugal force torque is contracted by the normal reaction produced by the outer tires. Okay, and these two torques cancel each other out, and which help the car or the automotive to stay rooted on the ground and complete the turn. That's why having a wider track width is necessary. Let me show you another example. See this car over here. You see how it is, slightly loaded towards one side and slightly unloaded towards the other side, right? Loaded on the left and loaded on the right. It's performing a tight maneuver, tight turn maneuver, and because of that, there is load transfer happening over here. Okay, the outer wheels are facing more load, and inner wheels are facing lesser load, and this is the angle by which the uh, body of the car is being tilted. When you have a larger track width, this angle goes smaller. That means there is better weight distribution on both inner and outer tires, which means the car is more stable and under control. And rather than having the car, tip off, this is having a wider track width will always help to achieve that, much required control when you're doing, when you're going at top speeds and or when you're doing very tight maneuvers. Always track width wide. That's what helps you. Okay, so now we talked about the two fundamental dimensions of automobile, the wheelbase and track width. Now let's move on to center of gravity. Now, you might have encountered this concept of center of gravity even in your physics class, right? There's a point where the entire weight of the body is assumed to be concentrated. Even here in automobile cases also, it's the same concept. So here, the weight of the engine or the weight of the motor, transmission, tires, chassis, you name it, whatever you have added towards your car or towards your automobile, the weight of each and every one of these components is assumed to be considered one single point, and that is called your CG. Okay, the position of the CG greatly influences the overall stability of your car and also the handling. Right. Now you might see supercars, right? Supercars will always have a low sitting or a low CG position with respect to the ground. So the CG height is lowered because that leads to a more stable configuration. And in terms of the lateral position, uh, CG is usually located at a distance which is half the wheelbase. The point where the normal reaction acting on all the four tires are equal, and this leads to the most stable car. If we talk about just the uh, chassis alone, then there is no way to change the CG, okay? Because once the chassis is fixed, it is fixed. You can't do much over there. But you can still make the changes when you have the suspension links on. So by modifying the suspension links, you can lower or increase the height of your chassis and set the CG height to a suitable level. Like I said, CG height, the lower the better, but don't make it so that in the process of lowering the CG height, you make the suspension too stiff. That makes the ride a whole lot more uncomfortable, and that will create more problems later on. So you'll have again, it's a matter of finding the sweet spot. Okay, lower the CG as much as you can, but not while sacrificing your suspension, abilities too much. Okay, maintain enough suspension bounds so that all the obstacles or all the cornering actions can be done more easily. I was telling you all these, the car on the left, okay, the supercars or the cars on the track, they always prefer to go for a lower CG. Remember, in the case of track where I told you, the larger the track with the better. Well, larger in comparison to what? The CG height. Okay, so if the CG height is lower than the track width, that would mean a more stable configuration is attained for the automobile, and with that configuration alone, you'll be able to do cornering, you'll be able to do acceleration, you'll be able to do deceleration more, more efficiently. Take a look at the car on the right. Okay, due to its higher CG, it will have difficulty cornering because again centrifugal force is in play, and the centrifugal force is more probable over here to tilt the car over and to make it fall over its side. Okay, and now finally the last concept, which is the chassis heights. Okay, so chassis height is the distance between the ground and the lowermost portion of your chassis. Okay, so look at the cases when you have lower chassis height and higher chassis heights. Okay, so when you have a lower chassis height, there is reduced airflow, okay, beneath the car, and what this does is that creates some sort of a ground effect. So when you're moving at high speeds, uh, since there is reduced airflow underneath, that means reduced air pressure, the car is being pushed down. Okay, and because of this, there is increased traction on the ground, and the car is able to throttle up very easily. It's able to catch speed very easily. It's able to brake easily because of the ground effect. Say if your chassis height was a bit more higher, if your chassis, then there's more airflow underneath the chassis, and because of this, there is more aerodynamic drag, and you'll have to, overcome this drag to reach optimum speeds. So higher chassis heights are generally not preferred. Again, the chassis height can be adjusted through your suspension links. So by adjusting suspension links at both front and rear, you'll be able to get the right chassis height. And if you're talking about lower chassis heights and you want to make it more effective at that particular height, then make sure that you have a flat underbody. Okay, when you have a flat underbody, the amount of downward force acting on the car is even on all the sides. So that way, distribution of force is equal rather than one side experiencing more force than the other. The cons of having lower chassis height is that there is less room for the wheels to travel. Okay, so the suspension travel is not being used effectively if you have lower chassis height, and it will become more of a rough rides. Okay, each and every bump will be felt more acutely. Okay, you can feel it more sharply. Okay, that's the whole point when you have lower chassis height. So, uh, if you're choosing a lower chassis height, be sure that the track you go on has very short bumps. Okay, not too high of a very short bump, so that you can manage the suspension. If it's too high of a short bumps, then your wheels will probably hit your chassis, and or it might not effectively use the suspension travel. It becomes uncomfortable. Okay, lowering the chassis height will effectively lower the CG also, and it will also bring all the other pros which I mentioned previously, like the stability, the comfort, and increased handling capabilities and all those stuff. So that's for the video. So in this video, I covered pretty much the very very basics of these concepts of wheelbase, track width, the chassis height and CG heights, and in the upcoming videos, in next video, I'm thinking I'll cover camber, types of suspensions. So yeah, these will be topics we'll be covering in the next video. If you have any topics in mind which you want me to cover, just let me know in the comments. And yeah, I hope you like the video. Do make sure to leave your review down in the comments, and I'll see you in the next one. Until then, see ya. This is Srihari signing off.